So this is a review of all the different types of factoring. And this is the order that you should look for, because no one's going to say, hey, factor this using difference of perfect squares. So I'm going to write the order, and then we'll go through an example of each. So the first thing you should always look for is a GCF. GCF is when you can take out a factor in each term. That's like the biggest number you can divide each term by. And then it's the smallest exponent you can divide each term by. It doesn't matter how many terms you have, so always look for GCF first. Then the next thing you look for is difference of perfect squares. That's when you have two terms. You have to have a minus sign, and you have to be able to square root everything. Next thing you look for is if you have three terms. That's a trinomial. And for Algebra 1 purposes, it has to have an x squared in it, and then two other terms, something with an x, and then a plain old number after that. The last kind I'm going to write over here is if you have four terms, and that would be a grouping problem. Sometimes in class I also call it double GCF. Those are the four types, and that's it. So let's go and look at GCF first. Okay. Get rid of this. Okay. So GCF. Remember, you can have any number of terms. So remember, for GCF, you are looking to do this first. So, and it doesn't matter how many terms you have. Wait a second. Oh man, it's early. So let's do 3x squared plus. So for this problem, we have 3x squared plus 6x to the third minus 12. So the biggest number we can divide into each one of these terms is a 3. Now there's an x squared, an x to the third, but there's no letter there, so you can't take any variable out. So here GCF is 3, and then you put your leftovers in the parentheses. So you have these little division problems. 3x squared divided by 3 is just x squared. 6x to the third divided by 3, let me bring down the plus, is 2x to the third. And then 12 divided by 3 is 4. Now I'm going to change up this problem a little bit. So if I have 3x squared plus 6x to the third minus 12x, now you can take a variable out. Remember, there's always an invisible exponent there, so our GCF now becomes 3x to the 1, or 3x. So actually, let me start that part over. So if we take out a 3x as our GCF, the 3's still cancel. You have x to the 1, because remember, you're subtracting exponents when you divide, plus 2x squared minus, those cancel out, and you have 4. Your GCF goes on the outside, leftovers go on the inside. Let's go to the next type. So now we have difference of perfect squares, otherwise known as DOPS, difference of perfect squares. Got to have two terms, and you have to be able to square root everything. So I'm just going to jump to like one of the trickiest kinds you might see. 36x to the 4 minus, remember, you got to have a minus sign. I don't know, 81 y10. So in order to factor, or in order to take a square root, you have to have perfect squares where you can square root 36 and get a whole number. Your exponents also have to be even numbers. If you have x to the 5th, you can't square root it right now. In Algebra 2, we'll work on that, but for now, you can't do square root. So difference of perfect squares, you do 2 sets of parentheses, one with a plus, one with a minus, and then you square root each term. So square root of 36 is 6. And to square root a variable, you cut the exponent in half, so that would be 6x squared. So that goes in the first part of each factor, each set of parentheses. And then we're going to, the minus sign, ignore when you do the square root. Minus sign has to be there, and that is taken care of when we do this, the plus and the minus. Okay, so square root of 81y to the 10, square root of 81 is 9. Square root of y to the 10 is y to the 5. Let's go to the next kind, which is trinomial. So that's where you have to have 3 terms. This is my favorite trinomial for some reason. This is also a quadratic expression because there's an x squared. So to do trinomial, it starts the same as difference of perfect squares. But instead of doing a plus and a minus, you put an x. And to factor this one, you find 2 numbers that multiply to your last term and add to your middle term. So in this case, it's 4 and 2, because 4 times 2 is 8. 4 plus 2 is 6. So you put a plus 4, and then you put a plus 2. Now this can get a little tricky when you have minus signs. Let's do x squared. Oh, let's stick with plus 6x. No, wait. Plus 2x. Still a trinomial. X. So now we have to find 2 numbers that multiply to -8 and add to 2. So I'm still going to use 4 and 2. But remember, to multiply to a negative number, they have to be opposite signs. So in my head, I think subtract. 4 minus 2 is 2. Now, you got to make it add to a positive 2. So your bigger number matches that sign, and your smaller number is the opposite sign. 4 times -2 is -8. 4 plus -2 is a 2x. The last kind that we have is grouping, which is 4 terms. Hopefully I can. I got to think about this now. Okay. Hopefully this works out. So we have 4 terms. We're not simplifying this. We are not combining like terms. So you're not going to turn this into x squared plus 6x plus 8. You're just leaving it. When you're factoring, you're breaking things up. So I'm going to group these. First 2 terms, second 2 terms. And then I'm going to take the GCF of each group. So the GCF of x squared is x to the 1. So if you take a GCF out of each one of these, you would end up with x to the 1 plus 4. And then I'm going to take the GCF of the second group, 2x plus 8. So that GCF is a 2. And you're left with x plus 4. Now you know you did grouping correctly if your parentheses match. So x plus 4, these 2 parentheses become one factor. And then your GCFs become the other factor. So now that we've gone through one example of each type, It's up to you to practice going through this and then moving on to more difficult types of factoring.